Hello, everyone. Dr. Hernandez and DJ. We're excited to present our project Confi. And in our introduction, we offer the future of tech prototyping and development. So our team is Chris Tuala, Sean Kushner, Rebecca Kimmick, and myself, Jasmine Pasio.
So one question we found asking ourselves was how many small businesses and startups lose critical time and money navigating the complexities of printed circuit board design or PCB design. With more and more small tech companies filling very niche markets within the industry, Confio really steps in. Confio aims to eliminate the hurdles and traditional complexities of PCB design by building a modular, fast, affordable, and reconfigurable platform tailored to your needs where no coding is required.
So what exactly is a PCB? So a PCB is the foundation that connects and powers all electronic components, and they are absolutely essential for modern technology and found in almost every electronic device, as well as they make electronics more reliable, compact, and affordable. So as Confio, what exactly are we doing? Well, we want to be a one-stop shop for PCB design. So imagine you're a power tools company wanting to develop a smart chainsaw. You have extensive knowledge in mechanical design of the chainsaw, but you don't have the knowledge in the embedded technology and firmware development, and you don't want to spend the extensive time, money, and resources required to develop a team or to hire a team and develop it on your own. So that's where Confio steps in. Confio steps in as a trusted PCB developer and manufacturer. Confio will handle all PCB development from design, manufacturing, and integration. Confio will use already established and trusted techniques, or already established and trusted modules to speed up development time while also ensuring reliability. So in this example, the company would like a motion sensor to detect falls of the chainsaw and shut off the device immediately. It wants to have a temperature sensor to ensure that the device is not overheating, and then a vibration sensor to ensure that the device is properly used. So as Confio, we would then deliver PCB within a 1 to 4 month turnaround time because we're able to use our pre-existing modules and configure it for the use case. So this is an actual working prototype we have that we have just printed from our manufacturing
facility
from PCBWay. So this eliminated the need for extensive research and staffing, as well as helped the business innovate efficiently with minimal investment on their end. So kind of going into why Confio stands out compared to other PCB designers is because since we're modular, our turnaround time is much quicker. So now imagine you are a construction company looking to develop a smart hard hat, and you would like to have a vibration sensor to detect impacts just in case of a impact to the head to ensure user safety. And since we already have a vibration sensor and a controller module made, all we need to do is reconfigure the pre-existing modules so we already have a starting point rather than starting from scratch. So then all we would need to do is develop a GPS and an air quality sensor to fit the other use case requirements, speeding up development time and also lowering costs. And then as Confio would continue as a company and develop more modules, you get into certain scenarios, such as this one where, for example, if a firefighter came and wanted to develop a new smart suit integration, and the requirements were to have a GPS, a temperature sensor, an air quality sensor, and a vibration sensor. All of these modules have already been made, and then that would even further speed up development time as we already have a base to go off of, and we only need to work on the integration into the suit itself. So kind of talking about the actual technical side, this is our schematic of our current prototype. In the top left is our controller module, and that's just the ESP32 S3 Mini, as long as with the boot and reset buttons. And then on the right is our power distribution, which is right now we're just taking in a USB-C and then also have some static protection, as well as a step down from 5 volts to 3.3 volts, just because that's what the ESP32 operates on. And then the modules are below. So on this device in particular, there's a LED module, which is on the left, and it's just a multicolor addressable LED, so we can kind of put out status signals or any kind of input that or output that we need. And then in the middle would be the temperature sensor, and on the right is the gyroscope. So then just kind of zooming in a little bit, we have the ESP32, again, so as we described, pretty basic, with just some capacitors for the power filtering. And then power module or power delivery module, which again is just a USB-C. And then the peripheral connections, which these would be the actual modules itself. So as Confio continues to develop, we would just use these exact footprints to speed up development time of the PCB process. So kind of going in a little bit more, the board itself, it's a 4-layer board. The power traces are 12 mils and the signal traces are 6 mils. And then on the layer 2 and 3, there's a ground plane. And then on layer 3 is where all the power traces are routed. And then the signal traces are on layer 1 and layer 4.
So to talk about the app a little bit, that will work in tandem with PCB. We'll go off of the chainsaw example that Sean talked about in the beginning. Yes.
Ain't no way I'm using an app for a chainsaw.
Hey, it's for the. So
Where you
I'll
set
draw
up
out.
your dashboard.
I'll draw out. So say that I'm the prototyper for the chainsaw, the power tools company, and I'm on the team that's working on the smart chainsaw. I want to monitor the temperature, the vibration, how fast this chainsaw is going, if it's like going the way that I need it to, or if it's going too fast in a dangerous manner.
Don't trust me with my own chainsaw.
Not as a not in the development stages. Anyway, so as a chainsaw developer or the smart developer, I'll open the Confio app as I receive the PCB, and I'll log in with my username and password that are provided with my Confio PCB. And as a reason that we provide a username and password is for that the app options that we'll get into later are only those that are available on your specific PCB, as Sean is showing. So that you don't have access to things that are not on your board and then leading to errors of you trying to configure things that don't exist. So once you log in successfully, you'll have 3 options. So the first is to connect to the PCB that you have. And this option will initialize either a BLE scan or it'll begin communication with Wi-Fi or cellular to connect to the PCB that you have. You can choose the configurations, which will select the configuration preferences that you want to send over to your PCB over that connection that you have. And you can also open the database, which will transfer the PCB data, the data that's on your PCB that you've been collecting with your configurations, to be sent to your personal Confio database. So if we select the first option, which is connect to PCB, as you mentioned, it'll show the connection status, so it'll be connected or not connected. And then if it's connected, it'll have the red button, which will allow you to disconnect. And then if you are not connected, then it'll have that green button that'll do that scan that I mentioned earlier. And then below this button is a communication method option. So for the chainsaw example specifically, the power tools company has decided to have BLE, Wi-Fi, and cellular on their PCB. But in the case of the firefighter helmet, they might have only wanted cellular because that's more appropriate for the use case. There's not going to be Wi-Fi in a burning building, so you probably want to use cellular for the communication. Yeah. So if we choose change configurations, this is where we'll set the presets that allow you to change the data configuration preferences or set actions to change the behavior of yours. So under preset 1, in this case, we selected the button that's on the PCB, and in the drop-down menu above, it only has the modules that are on your PCB that you've ordered. So we've selected the button, and then under data collection preferences, I've chosen to collect the number of presses and the length of the presses, and that's the data that the PCB will collect over time. And then on this side, the second preset, which we've added just by pressing this button, we've selected the temperature module. So rather than focusing on data collection, we've decided to focus on actions. So in this case, we've decided to have when the temperature module reads over 90 degrees Fahrenheit, it'll stop data collection and power off the system. So this is really useful for instilling safeguards and protecting the safety of the prototyper, or in late stage, the end user. And then once we're done, we'll save our configurations. And the PCB will start collecting data. So after a while, we've collected some data with our PCB. And now we can open the database and see that the number of presses that was collected was 50. And the average length of these presses was about 2 seconds. Under the second preset that we set, which was that temperature module that I mentioned, it says that the times that the temperature reached the threshold was 12 and the average temperature was 85 degrees Fahrenheit. So what this means is that 12 times the temperature module read to 90 degrees and powered off the system and stopped data collection 12 times. And then average temperature is a useful statistic to have. And then we can also open the full database, which will show all the entries of the database. And if we wanted to see the actual length of each of these 50 presses, then we would do that because then you could see every data entry. Yeah. So this is the software stack and that we will be working with. And right now we're really at the top, but this is the structure that we're planning. So we're actually mid-level. So the first is the client layer, which will be the Android app, which is coded in Kotlin. And I've chosen Kotlin just because there's more support in the documentation, a lot more documentation, because Google for Android wants it to move into the Kotlin direction rather than Java. And then retrofit for the backend and Bluetooth low energy, as I mentioned, for the communication with the PCB, but it can also be Wi-Fi and cellular in other stages. And then for the application layer, this is Flask, Unicorn, and Linux. This is for the backend framework that is interacting between the client layer and the database layer. So I plan on using Python Flask to have that structure. And then for the database layer, just Postgres SQL. And for the server layer, we'll be just using Linux to structure the server on a local machine. Well, first it'll be AWS, and then it'll move to a local machine. Move to a local machine that will host the server in-house. So as Sean and I illustrated, the platform integrates seamlessly, allowing for companies to focus on innovation rather than stress about infrastructure. The modular PCB allows us to switch easily between clients and streamline production and delivery of product to client. And the intuitive app allows us to focus less on the stress of programming barriers that are required, or programming knowledge is required by developers, and allow more people to develop technology.
Again, the problem that we're trying to fix through Confio is that current PCP development is time-consuming, technically complex, and very expensive, especially for those small and startup businesses that do not have their own PCB development teams. And that is a solution that we are trying to solve. In the previous examples, we've used BLE, Bluetooth Low Energy, cellular, and Wi-Fi. And these can be used interchangeably, depending on what the user will desire. And this enables specific PCB behavior based on the requests. As for the cost of the manufacturing and materials, right now they start around $12 per unit. And using add economies of scale, this can drop to as low as $6 per board. As for the database, where we would store all this information, the cost of database storage on AWS is $23 per terabyte per month. And this allows us to start up more rapidly.
So the current market analysis of the global PCB market is estimated around $84.24 billion with a compound growth annual rate of 4.87%, 4.78%. And is estimated to be valued around $100 billion in 2030. So again, really emphasizing those challenges. We're going to get into like the specific costs in a minute, but the challenges are those high costs, the long development cycles, and then if a company were to choose to develop their own PCB design with app and using those development boards is very expensive and inefficient. Confio really aims for having a modular device, and since we already have those pre-built modules, we're able to speed up those development cycles, the cost that it takes to actually develop it, and we're production ready. So the current market demand using Upwork as a platform, we were able to do research and just searching for applications and what projects would really help. There are currently at least 68, and then goes on projects using specifically just the ESP32 chip. And something I want to highlight is that top left title, the IoT Smart Irrigation System Development ESP32 Mobile App and PCB Design. Wait, And so with that, is basically everything that Confio is really offering, and it's just showing how in demand that platform is. So comparing and contrasting Confio really has two main competitors, Arduino and another company, Particle. Confio, as we had said, is really targeting those small businesses and startup companies that really need help entering the PCB industry. Yes. We will get to that in a second. I'll go over this. Arduino is really aimed for the hobbyists and the educators. So we as college students have worked with Arduino. Some of the senior projects have that built into their actual project. And then Particle really aims for those IoT developers and the already really established businesses. One thing that really makes Confio really special is the no coding aspect, where with Jasmine already establishing the app, you do not need to do any coding for that, and they're able to configure the actual PCB board straight from that. Whereas Arduino and Particle really change. Okay. And then Arduino is really aimed for those educators who they're trying to learn how to code an actual component. And then Particle, again, really requires a company to have an already established engineering team that is able to code their device into production. The business models are all very similar, where there's a hardware sale, and Particle, like Confio, has the cloud subscription option. And
Good.
okay. And then I'll continue. So Arduino, they're mainly hardware sales with very minimal cloud support. Is it scalable? So Confio and Particle are both scalable. Confio is aiming for that small to mid-range scalability, where there are smaller businesses that do not need as much inventory that others would need. With Particle, they are really aiming towards those highly scalable companies that really want those large bulk orders. For Arduino, they really are not scalable option, since they have to customize the actual PCB design, you need external modules, which is not an option for scalability. And then the price per unit Confio is coming in around $20 to $30 per board. Arduino is being the most expensive option, around $30 to $150 per board, depending on what you decide on. And then Particle coming in a little bit more expensive than Confio is around $40 to $60 per board. And then the competitive advantage Confio really has here versus the current PCB market, with our research that we've done and the cost we have evaluated a company to enter into the current PCB market, it would cost them around $5,000, which includes engineering, the design, the assembly, and fabrication of the PCB. This is all on the assumption that there's a minimum quantity order of 50 boards. And then Confio, since we already have the modular design where we have the modules already built and we don't have to spend the extra time, we're able to cut down costs, coming around $4,000 per 50 boards, where that's still the same composition of engineering, design, fabrication, and assembly. And then the timeline, since again the modular design is really able to help us speed up production, it would take us around 4 months when a company were to come to us, versus another company around 12 months due to the actual beginning process of the design.
Looking at the realistic constraints within the company, we're trying to target areas such as social, ethical, political, and environmental sustainability issues. For example, our board should be low powered in order to minimize the energy use, and political, making sure that we're following privacy laws and following similar lines along ethical and social concerns. Realistic constraints are that economic, again, trying to keep that price low. Right now, as we previously mentioned, it costs around $10 to make the board. health and safety, making sure that all the standards are set. You know, you don't want to go around shocking people. And manufacturability, making sure that we're maintaining that low cost, along with that economics. Looking at the revenue sources for Confio, you'd be able to have direct sources, direct sales through PCB kits, as well as a subscription model, which would be either monthly or annual. And increasing in tiers results in more data being available to be put onto the database, as well as more consulting and maintenance support. As for the standards, we have the PCB design, the communication software and data and security all mentioned within the business plan as well, targeting specific IEEE standards that were in line with other people in the industry. Future steps would be, continue testing BLE connection, as that's something that's continued ongoing. We have the board made, so now comes time to develop the app further, and future senior projects can continue that project. And integrate that PCB, specifically with the app, but for those specific modules, let's say adjusting for the temperature, adjusting for motion, adjusting for GPS, and so on, among others. That's our presentation.
Thank you.
Thank you.
Happy to explain if you have any
Yeah.
questions.
Yeah, sorry, I missed most of it. So.
That's
Okay, we can go back to
Okay. So this is a modular system for putting together embedded designs. So
Yes.
Yeah.
So we entered in like the Mayo business competition at TCNJ. So this is more of like our business plan and whole senior project combined.
Okay.
So kind of like our idea was that like if a company or any kind of individual has like an idea for a smart product or anything in general, and they don't have like the knowledge of PCB design or embedded firmware development, we kind of want to make that process as easy as possible. So like for our example, like if you're a power tools company and you had the knowledge in like the mechanical design, but you didn't want to hire an entire PCB development team and start from scratch, that's where we would come in, and we would work with them as their PCB development and the design, manufacturing, also integration into the product. And then we would use like already established modules, so that our turnaround time would be much quicker than just starting from scratch. So kind of in this example, to kind of break down the modules themselves. So like for a chainsaw or smart chainsaw, you might want a motion sensor to detect falls and turn off the device to ensure safety, a temperature sensor to detect like any kind of overheating, and like a vibration sensor if it's being improperly used or overloaded. So then Confia would kind of deliver a PCB using our modules. So at the top is our controller module. Our motion module is right below that, which is just a gyroscope that can detect both motion and vibration. And then there's a temperature sensor, as well as external controls to power on and off the device. And then like where that business side comes in and what Confia is really trying to do is to be reconfigurable. So using those already modules, if a construction company wants to develop a new hard hat for their employees or input some kind of technology, such as like a vibration sensor to detect any kind of impacts to the head for safety, as well as we already had that controller module and vibration sensor designed and tested. So now we have already a starting point. And if they just want to add a GPS just in case of an emergency, or an air quality sensor to detect like improper working conditions, rather than starting from scratch or them hiring an entire team, we can just add these two modules to our previous design and then configure it for their use case. And then as Confio continues to develop as a company, such as like a firefighter wants to embed something into their suit just to detect any kind of different environmental conditions, we already have, and their requirements are like a GPS in case of an emergency, a temperature sensor, and an air quality sensor for like the buildings, obviously, and also a vibration sensor to detect any impacts. We already have all those modules together, so then Confio would only focus on integrating it into the suit itself rather than designing the whole PCB from scratch.
And so you have plugs and sockets with like I2C communication.
Yeah, exactly. So all these like modules kind of on the schematic is going to be communicating over I2C. So in the ESP32 is at the top left, which is like the controller module, and then just in this scenario, which is on this actual board itself, and down below is just an LED, which is addressable just to like status. And then the temperature sensor is in the middle, as well as the IMU is on the right. And then kind of going in kind of goes through it. This is just the board breakdown. But basically what we would do is like based on the footprint, because we have already these components tested and routed, you just kind of plug it onto a board rather than kind of starting from a whole scratch and design standpoint. And then that would all work with our app, if you want to
Yeah,
briefly go over that.
so the,
There you
So this is, so these aren't necessarily individual boards, or are they just designs?
It's designs that we want to put on a board. Yep.
Way or whatever.
Exactly. So we want to be able to, so like in Arduino, for example, where they have like all the external modules, like you can't manufacture that. So like you have a prototype, but we want to be like a fully manufacturable, like kind of have that idea or inspiration from like a more modular standpoint. But if we hand them the design, then they can go to a manufacturer. We can handle that like PCB way, which is who built these boards, and completely just mass produce them.
and then the point of the app basically is because we want to remove that barrier of programming knowledge from people who want to develop technology. So once you open the app, you can connect to your PCB either through BLE or Wi-Fi or cellular, which is the future stuff. Change the configurations, which is kind of like the main point of the app, and then open the database to review your data. But can you go to the change configurations? So basically the point is that you select from the modules that are on your PCB. That's all that would be available. So for the chainsaw, in the dropdown would be like temperature, motion, vibration, and any other modules that were on there. I think that's it. So we'll go here. So for the temperature, I can select like I can select like collect the temperature for X amount of time, or like only collect the temperature when it's above this amount, this degrees. Or I can put an action in, which is more like behavioral things. So I can do a threshold value. So when the temperature is greater than 90 degrees Fahrenheit, I can stop data collection and power off the system. So more for safety and security things. In this case, or for if I want to do vibration, I can, when the vibration reaches this, then stop to power off the chainsaw, and things like that. Then with this, you would just save, and that would send all the configurations over through binary bits to the PCB. And then the firmware on the PCB would receive those bits and understand what the configurations are to be. And then collect that data, and then that data will be resent over to the app once you open the database through that same connection. And then you can look at all the data, you can open the full database, which will show like the timestamps of everything, the actual data entries and everything like that.
Yeah.
That's the whole idea.
And it's, looks promising, I imagine. Useful for people who are only doing small quantities of production,
Exactly.
or so very small amounts, or of course they're prototyping to train folks.
Yeah, that's exactly what we're aiming for. It's prototyping and then startups and small businesses, like passion projects, really.
Right. So it's yeah. Because once you get to large scale, then costs of it's matters. But
And if they're getting to that point, they probably already have a PCB team already established. Business.
so and I'd say that in the world of startups are trying to get into a market, a 20% advantage in price is not good enough for trying to break into a market, but the much shorter development time is a big advantage.
Yeah.
And that was what I would say to lead on. Usually, I mean, most things, if you're making a startup to compete in the industry, if you're not cutting the price, by 80%, then you're gonna have a hard time breaking into the market.
Yeah.
But the time factor for development, turnaround time is much more promising. That's what development is. I guess you're. So this is mostly so the software wise, it's basically for reading out sensors. Design what you have to do. So it's remotely sensing things. There's a company I'm working with at the moment And they're developing an IoT thing, which, you know, this. I'll just tell you what it is, and see what your thoughts about it is. It's making a system to monitor air filters in HVAC system, air conditioning and heating systems, usually for industrial buildings. The idea is that they, especially a lot of industrial applications and hospitals and things, use a lot of air filters. They go through them when they're dirty, they need to be changed. If they change them too often, it wastes a lot of money. If they don't change them often enough, it's a lot of disaster. You know, something gets contaminated or whatever. And apparently, as an example, your typical hospital apparently spends $100,000 a year on air filters. Wow. I never knew that before I started looking at this. Yeah, surprising amount of money.
That's insane.
Yes, because they need their to clean. So this is a system that basically has an arm that comes out of it that moves across the air filter to transmit light from one side and measure it on the other side. So really two arms. And that goes back to the system, and it's sent through Wi-Fi or cellular over to some remote monitoring place that the results looked at, and then from the optical measurements, you can figure out how the state of the filter and whether track its deterioration of getting dirty and when it's changed. So that has LED driver for high brightness LEDs, as well as a photodetector, but also a motor controller to drive a servo to control some motors to move it. Temperature sensing as well. It's got the ambient conditions, things like that. This affects how the LED works and stuff like that. Could you imagine doing something like that? You're working with that for this sort of thing?
Yeah, it would just be modules on.
Yeah, I think like the arm part is probably not where like our focus is, but in like more basic scenario, if you just want to monitor like the air quality, or like a hospital when it needs some kind of room or a little device in each room to measure particles in the air, like that's kind of more of what we're targeting. Where this is either like an all-in-one solution or going into it something that you already have.
So I'll imagine that you need to have a broad variety of capabilities.
Yeah.
You can customize things so that you can do stuff that someone can't just buy it off the shelf now or
Yeah.
Which could be motor drivers or which for movement, or it could be I don't know, all sorts of other more unusual sensors of this and that. So they're trying to measure wind speed, oil pressure, or collection of capability is that someone can't just already buy some little board that's ESP32 that already has all of that.
Yeah.
So what do you guys plan? Are you going to try and turn this into a business?
So
So
I think that
we did compete in the Mayo Business Plan. They said they're out of how many? 12?
Third out of 12 teams. Yep. So we, being in the first three, you take part of the 60K prize pool, which is great.
Great.
Yeah.
I know Dr. Dietz has really talked to us about kind of establishing a presence, thinking about taking on projects as long as we get the app functionality and connection.
And then like it being a senior project, there's also another team already lined up, like the legacy part where they can get more depth, or if they actually have like a project come, they can actually work on an actual use case.
Great. Well, good luck.
Thank you.
Yeah, we did present.
Happy to tell you all about it.
Yeah.
This is the first time I see it.
It's like our question.
Yeah.
It's all of your seniors.
Yeah.
Yeah. Almost there.
It's there. You want us to go back and
Yeah, I was running late and I thought, well, usually they start slow anyway, so I, I obviously missed a lot.
we did have all of our technical stuff ready to get our presentation.
Yeah, probably more just in the foundation there, especially I do embedding control development, so I'm interested in more of the.
We just give it free.
Yeah, so like what we're do this. What we're trying to do is like as you said, we mentioned in like the mega business plan competition. So it's kind of like a senior project as well as like a business use case. So as like a company Confio, we would be targeting small businesses and startups who don't have either the money or the time allotted that they can just invest in like a whole PCB development team, as well as like embedded firmware and stuff and control. So like kind of what we want to do is be able to take, for example, I'll skip this. This isn't more. So for example, like a construction firm who wants to just embed something small into their hard hats without spending the extensive time, money, and resources required for their own team and just kind of focus on employee safety. They could reach out to us, and then we're kind of trying to target like a more modular design. So through like more clients and use cases, we would start to develop modules like a motion sensor that can detect vibrations. And then like our ESP32 controller would be kind of like the heart or core of the system.
Basically a library.
And then
Like,
we would pull from like different schematics and just kind of fit it to their use case. So rather than like retesting and reconfiguring everything, we already have a starting point. So in this example, kind of mentioned in the previous presentations, we started out with like already having a working vibration sensor, but rather than starting from scratch, in this use case, they want a GPS just in case of an emergency, as well as an air quality sensor to monitor working conditions. So we would just develop those two new modules and put it on a board, saving time and cost because we don't need to go through testing. And then all of this would just work with an app, either for prototyping or actual implementation where we could give like custom templates and GUIs, like in the case of like a GPS where you can actually like monitor and track employees in case of an emergency. But for this example, like it's a temperature, if the temperature is like greater, or maybe that in the hard hat condition, if the air quality or particles something is too high, it could alert like the wearer user. And that way they can just prototype quickly or have a fully working and manufacturable board, rather than struggling with like Arduinos and learning code and then modules and then going from there and then making a new PCB that is actually manufacturable. So that's kind of like our business plan in general.
So how does it reach the phone? Or how is the data getting from the board to the phone?
So this board right here has both Wi-Fi and BLE. So in this case, we're working with designing an app and communicating over BLE because if you have I guess Wi-Fi, like if you're in like a remote environment, you might not have like an actual network. But then we would also explore in like future iterations, maybe like a legacy team next year would be like cellular and implementing that on board. So if you're out in the field, you're able to communicate anyway, regardless of the communication method. And then all that would be dependent on like the company's requirements. So if they don't need Bluetooth and it's only like a cellular thing, maybe going on a truck somewhere for a trucking company, that will just remove that entire module and just completely lower cost. So rather than like having an all-in-one solution where all these different things are here, we want to keep it as small and compact as possible with like minimal, just what fits the use case.
And what development environment is it encoded in? ID was, or more importantly, like this language, like both really?
Yeah, so
Making an Android app right now.
Android app. So in terms of ESP32 firmware, that's just I'm using like a mix of like the Arduino IDE with that like C language, as well as there's a Platformio on VS Code, which is kind of for Arduinos and ESP32s, as well as just the ESP32 IDE, because we're running into like a lot of bugs and stuff. So as like we import libraries and making sure things are up to date. Sometimes one just works better than the other, seeing what works best. But in terms of the app, you wanna-
Oh yeah, so the app is being coded in Kotlin, which is just what I chose because the online Google and Android documentation has more support for Kotlin because they're trying to push developers to code in Kotlin. That's their kind of language rather than Java, and they have more control over Kotlin because it's it. So yeah, that's just the app.
Yeah, I mean, so essentially your value proposition to a company, a tech startup, is that you can help with rapid prototyping and also bring them, hopefully fill an expertise that they might not.
Yeah.
And
Yeah.
hard hat's a good example.
Yeah. So even like if it's just an individual or maybe like a firm that has nothing to do with technology and just wants to make like a smart device, that's where we would come in and handle everything.
Yeah, I work peripherally at a tech business incubator in Philadelphia, so I see more of my share of entrepreneur come in and have an idea, but no idea how to technology work. They bring in somebody from college and start some of their control projects, but they're just reusing code they saw, you know, on a blog or a magazine and trying to deploy it.
Yeah.
I mean, you know, it's a good first step, but it isn't a path to releasing the product. But you know, getting early feedback on the product really helps. So even if this wasn't the ultimate solution, although, you know, arguably could be, at least getting quick feedback. You know, there are bodies of code that will target Arduino, or better yet, ESP32, which is really the same thing, except on steroids. Yeah. And so cheap, so why buy Arduinos unless it's super thing. As far as it seems, but best example I've seen out there, you guys might want to consider it because you probably just adopt it into your suite. Kind of focus on the hardware and the interfaces, or customizing your hardware. But flow code, it's been around, I don't know how many decades, but the companies recently produced flow code 10. It is an amazing rapid development environment that ultimately codes in C, but you can code in anything you want. Pseudo, flowcharts, and a couple of languages, and then just compile it and it shoots it down to the target. The target can be anything. You might put your pick. It could be Arduino, it could be ESP32, it could be a Raspberry Pi. And the thing is, once they produce their body of code, it comes out well documented. You can add your own customizations to it, and so it's a real good kickstart. And then from there, you could arguably stay in flow code, but you could write your own libraries in flow code and add to theirs. And they changed their business model from actually a moderate cost to free for makerspaces or non-commercial. So you can find out it'll work for you without any cost.
No, that's awesome. Definitely write that down.
Eventually make your hardware a target for flow code. So you don't look at flow code 10. The company's name is Matrix. They're UK-based education company.
No, thank you.
Yeah, Mike Mesh 12, see a lot of software programming. These guys have been doing it for decades. They have a passion for it. And I've watched it, and, you know, I've evaluated over the years, and it had problems, but not ready for prime time. Except for their target market was educated students anyway. But I think they now, with Level 10, have achieved something that you can consider essentially a tool chain used by a professional. I can't guarantee that that's true.
No, that's awesome. Thank you.
Yeah.
Yeah, I came in here out of curiosity. I was played out. I was interested in another rapid prototype and better control. I tackled this years ago, doing engineering consulting up in New York for aerospace companies, figuring out how I could produce prototypes quickly. And you know, it's a tough nut to crack. But of course, things get easier. It's like 20 years.
That's exactly why we kind of started this project as our senior project, because our advisor was a consultant. He kind of dealt with that kind of stuff. going through his own testing process, making sure the board actually works when we do.
One thing I see come through the tech incubator a lot is people setting up these embedded controllers and trying to be their own access point. And if they're in a campus environment like this, the campus already has that system.
Yeah.
And so, oh, you got Bluetooth. Well, why don't you use the Bluetooth to set up the watch? Just
Yeah.
join the campus.
Yeah, exactly.
You have to transfer. Yeah, this I think shows naivete with regards to how things really have to work.
Mhm.
Now, of course, there are times when you want it to have its own access point, but it's mostly you stand out in the field.
Yeah.
You're trying to work, you really should just be able to do it.
Mhm. Yeah, and that's just the use case. That's why we have or the three main options would be Wi-Fi, Bluetooth, or cellular based on, ESP32 can do Bluetooth and Wi-Fi or access point all the time anyway.
And when you say cellular, by the way, keep in mind LoRa is really low cost and exploding, and that'll get you a quarter of a mile. And it doesn't cost much at all. So it doesn't cost much per node. And there are cities like Philadelphia where Comcast is trying to build lower infrastructure. So you actually just kind of be an alternate for they're your carrier for lower, taking it beyond 4 miles. But 4 miles is pretty far. And so you can you should consider putting LoRa as a supported interface quite a bit. A good example of a product that came to market using that is YoLink, YoLink. They have a whole suite of building control and monitoring products, which is really cheap. It's like $30 a module to monitor almost anything.
So then a lot
I'm
of
gonna hit that.
in our upcoming meeting, definitely a lot of things. So thank you for coming.
Yeah.
That would be neat, the next senior project to take on cellular and see that in the field. That is a great idea. Again, one of the value propositions is that initially for this first, because the minimum order is 5, right? It's $12 per unit. Though if you order more than say 100, it can go down to $6. And the ESP32 can be found online, just the chip itself, or like $1. It's
so
incredible.
expensive.
It's incredible.
I can't understand. I've been in business since there's been a business, and I still look at it. I can't believe it.
Yeah.
Yeah, it's
I
incredible.
designed integrated circuits in my younger days, and I still can't believe the cost of that stuff.
No, it's incredible.
Yeah.
It is. It really is.
That's why it'd be a high margin industry, right? Most of it's coming from that technical expertise, right?
Well, good luck to you, and I think you've got a great idea as a value proposition.
Thank
I
you.
appreciate it.
Yeah.
Thank you.
I
think that's our time.
The quickest
Oh, sure.
in one slide. Here we go.
Well, do you want me to give you some background here?
Yeah, if you want to get back.
Yeah, so this is Confio is the business plan that we submitted to the Mayo Business Plan Competition at TCNJ. So if you get in the top 3, you get into the prize pool, getting a part of the $60,000. So we ended up out of 12 teams, we ended up in 3rd place. And this is the presentation that we gave at the end. It also has around a 20-page business plan that was associated with it, along with a bridge document. It was judges who were in industry. Some people had their CPA, some people were fraud auditors, right? All TCNJ alumni came. And so this is the presentation that we gave.
Yeah. So kind of what our business is, that last sentence really sums it up. We want to eliminate hurdles of traditional PCB development with fast, affordable, and a reconfigurable platform with no coding required. So that means basically we would work with a client and for an example, if you're a construction firm and you want to have a hard hat for your employees and all you do is construction. So you don't want to reach out and have your own PCB development team and design and all that stuff. You would work with Confio and we would embed through our trusted modules based on other clients. So say we already had a vibration sensor made or an IMU unit. We already have that tested. It works, communicates with the app. Then we only have to add 2 more requirements. Say if they wanted a GPS in case of an emergency, as well as an air quality sensor for working conditions. Now, not only have we stopped starting from scratch, so we only need to develop these 2 modules, quicker turnaround time. Now we also have these for the future. So if like a new firefighter company or whatever wants to embed something in their smart suit and they just want to have a GPS, like we said, a temperature sensor, an air quality sensor, vibration sensor, all that stuff's already made. So all we need to do is focus on the integration.
We built it.
Oh, you build?
Yeah,
Yeah.
we're designing all the modules.
So like our goal is
Like over time, we'll have a library
Yeah.
of modules that we can just.
Yeah.
map to the
So it's
board.
like rapid prototyping. Basically we want to be able to not like for an Arduino, for example, like you're kind of finding all these external modules and like wiring it together. We want to have,
Yep, they're right up here if you'd like
Yeah.
to see.
we want to have like a fully manufacturable, like already product PCB ready to go, just in case if it would work as a prototype, they want to continue. So
It's like
these were made
plug and
with-
play. Like we already
Yeah.
have them. We already just have to design. Like,
Yeah,
just
it's on the
plug and
two
play,
editions.
we're already designing.